Hello, everyone. Thank you for tuning into the SNIA Storage Networking Industry Association 2022 conference. I want to thank the association for the opportunity that they have given me to present in this year's conference, and thank you for everyone who have spent endless amount of time trying to make this event a success. Without further ado, my name is Dia Ali. I'm the Global Solution Lead for Hitachi's Data Intelligence business. And in today's session, we're going to talk about an object storage framework, something that we put together to help organizations along their cloud journey. Whether you have an existing object store or you're evaluating the investment in a new object store, this framework will help aid you and guide you and give you the tools necessary to make the right investment decisions. So without further ado, let's dig in. Organizations are asking, how do we get to the cloud? Currently, the central question that businesses are trying to answer is, how do we evaluate the investment in modern object storage service? The challenge is that internal SLAs among business units must be examined and potentially modified to account for updated standards in data services and control offered by modern object storage service. This means organizations that delay investment in object storage services are risking competition gaining advantage against them in their core business market. It is critical to have an object storage service framework to define the business's focus and aid an organization in answering the question of how to evaluate their investment in a modern object storage service. While we review the framework, I want you to think of your interactions with your internal business unit functions while using this framework to evaluate a modern object storage service. The advantages of the object storage service framework is to provide a vehicle for evaluating your business unit data service commitments while guiding the object storage service assessment. In the next few slides, we're going to talk about three topics: cloud or no cloud, object storage evolution, and object storage framework. The cloud has been adopted by every level of IT organizations. The startup and small business sectors embrace the instant access to resources they traditionally could not leverage early in a market cycle. The medium to large business sectors are pushing hard into the off-premises cloud options for cost savings and simplified management. The juggernauts of businesses are whispering that they are all in with cloud adoption. So why are we still developing on-premises solutions? The reality many early cloud adopters have come to terms with is the cloud must include an on-premises component. The hybrid cloud is the answer. Defining a framework for object storage services referred to as OSS framework will lead to a greater adoption and investment in the cloud. A true framework provides a process to evaluate current and future cloud-enabled technologies. During this session, we will describe a framework for allowing a modern approach to how OSS should deliver intelligent data services. IDC published the Cloud Outlook forecast showing path ahead for cloud. Now, whether you agree or disagree with the forecasted numbers here, one thing is real, and that is businesses as well as the market is shifting to a digital-first world. In this world, current and past practices will no longer be enough and adequate to sustain businesses. There is a need to explore and evaluate new technologies that are in line with new markets. Change is a crucial aspect of growing your business. Such environments or such evaluation comes with a set of challenges. What tools and standards do you use to measure if your investment is worth the opportunity? During this presentation, while together, we will explore a framework for an essential component of the puzzle, which is the object storage services. With the advent of cloud services, IT is transforming and evolving from being a traditionally data center centric to being more like data centric. It's not a secret that we are seeing a shift in how organizations are looking at their data centers. The data center is no longer a physical location. It extends beyond the walls of the enterprise to the cloud and to the edge where majority of the data is being generated. Enterprises today are embracing the value of leveraging services from multiple cloud providers as part of a hybrid and multi-cloud strategy. This vision and state of operations to moving applications and data to public cloud platforms comes with a set of challenges from technology, operational management, security, and financial issues. It also involves adopting new operating models and architectures from SaaS model to a PaaS, on-premises to cloud, and from containers to Kubernetes, not to mention the set of high-value legacy applications that are critical to the business and pose an obstacle to the cloud strategy. Data has its own personality. Managing and protecting your business data is a critical component of your IT strategy. People need to create and access data across all their devices, as well as in the cloud, mainly to become more productive. Meanwhile, there is a strong focus among them for data management efficiencies and cost optimizations. Wherever data is stored, customers expect that it is uniformly secure. Organizations realize that the path to true multi-cloud environment and strategy begins by building a highly available, performant, and scalable object storage service, OSS. A mature object storage builds a healthy ecosystem of ISVs and products and tools to augment and complement the architectures and the use cases. Most organizations have multiple environments that are being evaluated for modernization and cloud. Such environments span a multitude of use cases that are classified by the types you are going to see on the screen, starting with the more traditional data protection use case on the far left. This is generally your backup environment, and the recent adoption of S3-based storage as a primary storage library provides more secure options like immutable backups using S3 object lock capabilities. From there, the same organization began to expand the use of object storage services into file services and adopting cloud file systems for workload sharing as an emerging use case. During this chapter, along the journey, organizations begin to offer modern hybrid cloud capabilities that leverage existing infrastructure investment and take advantage of minimizing latency and make the most of on-premises data gravity, allowing user data to straddle on-premises and cloud installations with easy and efficient ability to operate on user data. The next chapter for customers is the acceptance and implementation of cloud protocols. In the development of new applications as a reasonable first step to infrastructure neutrality. At this stage, those applications are more likely to benefit from hybrid and multi-cloud services. Organizations know that big data environments such as Splunk and Hadoop continue to grow exponentially. So in parallel to the cloud application modernization stage, big data environments are feeling a lot of pressure from the advancement in S3 cloud protocol services and modern integration options that have proven to be very effective supporting existing workloads. To list few, Splunk Smart Store, Spark, Presto, and the likes. For big data environments, there are three important optimization solutions to satisfy the wide range architectures for different customer deployments. Whether your current architecture is more suitable for a straightforward offload technique to inline optimization all the way to a more innovative modern alternative options. All three options offer various degrees of hybrid and multi-cloud deployment. The last area organizations are investing in along their journey comes in two folds. The first leg is the transformation of the object storage service into an intelligent data services platform. rather than just being a storage target. This is where organizations begin to evaluate modern hybrid cloud capabilities that allow users to straddle on-premises and cloud installations to create workflows that offer easy and efficient ability to operate on their data. Transform data efficiently by creating it on-premises and then leveraging cloud services like AWS transcoding to operate on the data. Transform it in the cloud and then return the outcomes of the processed data on premises where it is protected, indexed, and analyzed. The second leg addresses extreme performance use cases. Organizations in many industry sectors need to unlock the full potential of data and advanced analytics. For example, in financial services, real-time analytics is needed for fraud detection and risk management. But we also know that data continues to grow exponentially, and it's no surprise that scaling data sets to extreme capacities while maintaining the maximum performance demanded by data-intensive application is a real challenge. Reason why organizations begin to evaluate a parallel file system solution into their roadmap. A successful parallel file system solution should offer fast shared file system with GPU direct storage and unified protocol access to your data, whether that is NFS, SMB, POSIX, S3, or CSI, and comes with zero performance tuning to support small and large files simultaneously. Also, the ability to be deployed fully on-premises, hybrid, utilizing cloud services to offer customers with multi-cloud deployment choices is key to successful parallel file system evaluation. Organizations recognize that they are on a cloud journey to solve a problem, reach a goal, or achieve an aspiration. Object storage is a service to help embark on this journey with you and have what it takes to help in the transformation of the environments and use cases we just discussed. Organization starts to accept that existing storage solutions that they have implemented over the years are turning to be unsustainable in terms of cost and manageability. The most promising solution to next generation storage system is the object storage service. However, most end-user applications have not been natively designed to take advantage of object storage service. For many reasons, object storage service must evolve with new requirements that stem from the need to be compatible with existing legacy application and or existing infrastructure. This is mainly true in enterprise businesses where over the course of running in the data center, they will accumulate large repositories of data, creating data lakes and data oceans, and work with an ever-growing number of applications. Choosing the right object storage service today is an important decision on your path to cloud and toward modern infrastructure that will help you stay competitive and evolve rapidly to adapt to ever-changing business necessities. During our time here, we will discuss a framework to be considered if you are assessing and evaluating a new object storage service, or if you already own an object storage service and wondering if it is still viable for your business and service competitiveness in the market. We're going to talk about three different planes. The first plane is the physical plane in this model, and the physical plane facilitates an architecture which supports elastic capacity and simplified storage management. This framework abstracts a pool of resources that are consumed on demand and in any increment. Services in this layer provide atomic data abstraction of a pool of resources that are consumed on demand, and in many cases in any increment. Services in this layer provide atomic data operations that adheres to industry standard security practices, one that guarantees data authenticity, integrity, and durability. The second plane is the data services plane. The data services plane automate the complexity of enterprise data, unlock new data value, control the operation of the underlying data services for that data, and further enrich the information. The data services plane ensure that the blueprint for the data, allowing it to be a single source of truth. Presentation of the data through this rich metadata services layer provides additional multiple values of that single source of truth. Data governance policies are enforced across various repositories as data is self-describing and independent of the storage medium, as well as the application that created it. The third plane and the last plane in this model is the presentation plane. This is the object storage service entry point to end user, which means end users interact openly with applications that implement an element of interaction between clients and object storage, such as backup applications, file system gateways, and other modern cloud-capable applications. The adaptive protocol layer exposes services to clients using a set of high-level APIs. Current commonly used cloud protocol is RESTful, HTTPS. Also, block network storage protocols such as SMB and NFS. Client applications directly integrate into the presentation plane through a programmable layer using a set of functional interfaces. Now let's dig deeper into the layers within each of those planes, starting with the physical plane. In the physical plane, the first layer is the dynamic scalable layer. The dynamically scalable layer is a layer where all object storage services are expected to scale across access and storage. Traditional object stores were built with inherent scale limitations. They can meet most modern workloads, but the mechanisms that are deployed and used to expand the object storage service is difficult and intrusive. Performance is guaranteed to be impacted by rebalancing any additional resources. Even if you planned it around your peak workload, it's going to take an extended period before the added resources are available for use. The myth that new and more powerful hardware can alleviate this process is untrue. The hardware is less impactful in this process than the software. The reason is that the object storage service is architected to distribute data services evenly across all nodes without regard for hardware accelerators. The dynamic architecture to distribute data services, the dynamic scalable layer combined with larger capacities start to boost the availability of the newly deployed resources. The second layer is the abstraction of the data topology or data technology layer. Consistent data management policies across heterogeneous data repositories in a multi-site deployment protects data at scale for different repositories and for workloads across on-prem and hybrid and multi-cloud environments. This layer implements a programmable data plane technology that will help enable the logical reconfiguration of the underlying object access. This is a key driver toward realizing the next generation data neutrality and application flexibility. Design goals for this layer will be to focus on autonomous target decision and abstraction technologies. Target choice is based on clearly defined policies or the self-describing nature of the data. The data technology layer will simplify data representation and create an information fabric to route data based on its value. The second plane is the data services plane. Jumping through the layers, the first one is the autonomous services layer. The autonomous services layer uses near real-time intelligent automation and event or pattern detection to provide advanced levels of autonomy by scaling services across data protection, self-healing, security, data lifecycle, governance policies, and service exchanges. The autonomy levels scale to support, assess, and accelerate decisions made by the active metadata services layer. The autonomous services layer fully automates the service requests from end to end, resolving issues before they even arise. The second layer is a workflow services layer. The workflow services layer is a decision-making layer and key to data routing decisions based on data value, a standard business process that is normally remote from where the data is stored is removed from the data routing decision. This layer allows the organizations to directly link business application logic to data service interaction within the data services plane. The workflow services layer aids in the simplification of applications by alleviating the need for applications to implement complex business logic. Applications can now shift the focus on the creation of self-describing data that will influence how that data is managed and routed as it passes through this layer on the way to its destination. The workflow services layer processes business logic over self-describing data closer to where the information lives and is the goal of a well-architected modern active object storage service. The third layer in this plane is the active metadata services layer. The active metadata services layer correlates the logic flow of the business to the personality of the object. Not all data is created equal. To gain meaningful value, the data must have actionable intelligence that is enabled by a framework component that understands advanced metadata and tagging. This framework component also understands the language of the data. The resulting data is dressed in enough colors on its journey down the object storage service framework in preparation for the workflow service layer to make decisions based on the organization's business logic. Named levels of protection, authorized data targets, and preferred data routing destination decisions are examples of where the metadata services layer defines the decision tree within the workflow services layer. The active metadata service layer will enrich objects based on the business logic and rules that the organization has prioritized. The third plane, the presentation plane, has a couple of layers. One is the programmable layer. The programmable layer enables an organization to set boundaries and triggers to define the object storage service required to meet the business needs. This takes the concept of predictive analytics to an actionable outcome. The programmable layer dynamically enables external orchestration and automation services to define how the system is constructed. External system automation requests using the programmable layer are translated into optimal functions to restructure the system services through predefined APIs. The set of APIs in the programmable layer are also used by the internal architectural intelligence built into the object storage service to modify its own system services. An ever-changing system needs a non-static services manifest, which the programmable layer allows. The second layer and the last layer in this framework in the presentation plane is the adaptive protocol multi-access layer. The adaptive protocol layer is a collapsed protocol model with unrestricted user access. The access points are unbound by the limits of protocol requirements. Ingress and egress is limited by the nature of the protocol and not the architectural design of the object storage service. The adaptive protocol layer encourages hybrid adoption by bridging the gap between conventional data center protocols and cloud by generalizing application architectures. All end-user services and application interactions are activated through a mix of RESTful APIs and a set of commonly used standard protocols. A seamless end-user experience into the world of object storage service is met through the adaptive protocol layer. All right, now that we've spent some time going through the service framework, explaining the data planes and the different layers that are involved and how each layer functions and what kind of information that this layer contributes to the success of the business. Let's see how the data plane, the services framework fits into a real environment. If you think of any organization, they will likely have a data center that they have, over the years acquired multiple applications that are more traditional, and some organization might have implemented some cloud application internally on-prem, and they have multiple locations spread across different geographies, different continents, and they're looking at the cloud. How do we connect this data services that we have invested for many years with the cloud services that are being, positioned as, I have to go to the cloud now. I need to have a cloud strategy. But how do you kind of marry the two? How do you connect what data center deems as services and what cloud thinks of, the services? With the object services framework, the 3 different planes that are part of the model allows you to connect and make those decisions based on policies that are embedded within the business. Policies like what is appropriate to be on-prem and what's appropriate to be in the cloud. Why do I need to now use services in the cloud versus consume services that I have developed, within my data center? Do I need to develop services in the data center that exist in the cloud? Can I just, consume that? Is it more beneficial? Is it appropriate for this data to even, flow through from the data center all the way to a cloud storage target? Is that allowed? When and why and how? Can I deploy business logic to geofence that information within certain geography and only allow that information to flow from one place to another that has been designated and deemed to be, for example, secure or allowed or permitted for that data to live in? For example, data created in a certain country may have regulation that prevents you from protecting that data in a remote location outside of that, geography, outside of that country. So how do you make those decisions? Do you complicate the application's logic or take advantage of what we have described as the object services framework allows you to do? So with those 3 planes that are part of the model, that's where you start to make the connection between the data services that have been acquired, developed over the years in the data center, and this new cloud services world that you're trying to get into. And if we take the data planes out and break it out into the separate different layers that we have discussed, the model looks as you see on the screen. Those are the different layers, part of your object storage service, objects that are created, for example, inside the data center. They flow through these layers. They go through the programmable layer. They go through the active metadata layer. They flow through the workflow to make decisions. The autonomous service make decisions on data protection technologies, routing decisions, where to send it, when, how, why, is this object fit to be, processed? does it need to be retained for how many years? What is my retention requirement for that set data? And it makes all of those decisions based on the business logic that the organization have implemented and adheres to. So they might be under certain regulations, the governance regulation, where they need to, for example, keep data for 10 years. Like, okay, how do I define what data is appropriate to be kept for 10 years or 5 years or 10 years, or maybe this data is not meant to exist at all? How do I go and clean up information that is no longer needed and required? And if keeping it may pose a security risk for the environment, for the business. So all of those policies and regulations are enhanced by deploying an object storage service that kind of follow the OSS layers. You can absolutely configure those policies within your application. You can define it, but that will make the applications complex, and the knowledge of these business rules and regulations may be lost if the teams that have experience with that application have left the company, for example, when we see attrition. So in order to simplify the application and in order to disconnect the application from the infrastructure where the application now can float between on-prem data services and cloud services because there are no dependencies on the infrastructure anymore, the simplification of that application makes the data more agnostic to the storage devices that it lives on, the storage medium that it's being stored on, or even the application that created it. So, for example, you have an application today and you want to modernize it. You want to, just sunset it. You want to adopt a new type of application. And traditionally, you had to kind of migrate all that data, transform it, translate it, so that the new application would understand the format of that data. With the object storage services layer, once you disconnect the application from those level of details, the storage level details, which applications are not supposed to manage storage, leave that for a more sophisticated service like the object storage service, for example. So the application now is disconnected from that board and it can float between the two planes. At that point, the data is more flexible, where it can be created on-prem, it can be created on the cloud, and the application itself would understand that data regardless of where it was created or who created it. So there's a lot of benefits to the flexibility that the object storage service with this layered design allows you to enjoy. And then you start to slowly blend the data center and the cloud service and look at the cloud services or the cloud in general as an extension of your data center versus as a separate entity, as a separate location of your enterprise. So it becomes another location, part of your data center. During this session, we discussed a framework for allowing a modern approach to how object storage service OSS can deliver intelligent data services. While what we just reviewed is the cloud has been adopted by every level of IT organizations. The startup and small business sectors continue to embrace the instant access to resources they traditionally could not leverage early in the market cycle. The medium to large business sector continues pushing hard into the off-premises cloud options for cost savings and simplified management. The juggernauts of business persist in whispering that they are all in with cloud adoption. Therefore, the object storage service framework model is cornerstone of the object storage discussion. The future is hybrid. A true framework provides a process to evaluate current and future cloud-enabled technologies. This is all the time I have today. Thank you so much for tuning in, and thank you, SNIA, for the opportunity to allow Hitachi to come and discuss a storage services framework that organization can use and utilize on their cloud journey and adoption and evaluation of object storage services. With that, that's all the time I have today. Thank you so much, and I hope you enjoy the rest of the sessions.